Welcome everyone for the sixth day of the Python with Magicbit program. Today our lesson is Magic Talk. To do this lesson, we need the Magicbit and the MicroPython language related platform. So as the platform, we are using the Tony. So before doing any other thing, we need to have the Magicbit with the MicroPython firmware. So if your Magicbit don't have the MicroPython firmware, you can log into the Magicbit web uploader. The link to the uploader is there on the description box below. You can click on that and get into the uploader. And there you have to connect the Magicbit with the uploader and install the MicroPython firmware to that. After installing the MicroPython firmware, you can disconnect the Magicbit with the uploader and also you have to unplug the Magicbit and replug it in order to restart your Magicbit with the MicroPython firmware. So after that, you can close the uploader tab and now you can open the Tony IDE that has been already installed in your computer. So after opening the Tony IDE, you have to make the connection between Magicbit and the Tony IDE. So let's go to the Tony IDE and do that. So when you open the Tony IDE, it will look like this. At this time, you have to connect your Magicbit to the computer from the USB cable. So how you can connect your Magicbit with the Tony IDE is, so you can go to the Run option or the Run menu here and go to the Configure Interpreter. And there select this as MicroPython ESP32. And here you have to click the USB serial port in the list, or else you can click on the second option. And then once you click on OK, you will see this red color text will go off, and here this running button will appear to select. Let's click on OK. See, now the red color text goes off and this button is there to click. So that means our Magicbit is now successfully connected. Or else you can do the same thing from here as well. Here in the bottom, you can see the MicroPython ESP32 and the USB serial port. That is actually because we already connected it. Or else when you click on this, it will give you a list of selections. There also you can select the MicroPython ESP32 and the relevant USB serial. Okay. After connecting that, let's see what is our activities. I told you we are going to discuss the activity magic tone. So what is this magic tone? From this activity, actually we are going to use the inbuilt or the onboard buzzer and the push buttons in the Magicbit. We are going to press the push buttons, left or right push button, and to take a sound output from the buzzer on the Magicbit. So this is where you can see the buzzer next to the potentiometer or on top of the OLED screen. This is actually something like a small speaker. You can hear the voice. Not the voice actually, you can hear some sound from this one. This is what we call the buzzer. And last week, I think we discussed about the push buttons. These are the two push buttons. We are going to use one of them, left or right. Okay. And also we in the last week lesson, we discussed what is happening with the push buttons. When we press them, these two connections make the path and allow to pass the current. When it is released, that means when it is not pressed, these connections are open. That means the path is incomplete to flow the current. Now let's make our code. So in the code, first we need to import the necessary libraries and the necessary classes within that libraries. And then we have to define the pins of the components we are using. And we have to initialize them. So first let's do the libraries importing part. So here in the libraries, we are using the same machine library. And from that machine library, we are importing the pin class, PWM class. So you know what is mean by PWM. We discussed that part when we did the LDR related brightness controlling or light dimmer circuiting parts in order to write analog signal in the format of digital, we are using the PWM. And then we are importing the time library. From that time library, we are actually importing the sleep class. We are not importing the whole libraries. We are including only the necessary classes from them. And after importing the libraries, now we need to define or initialize the component pins. So I told you we are going to use one of the two push buttons in the Magicbit and also the buzzer. So first of all, let's configure or initialize the button, push button. You can use any name. So here I'm going to use the left push button. So I will name it as L button. And then as I imported the relevant class from the machine library, I'm going to use the class name directly. Pin within brackets. The pin number for the left push button is pin number 35. So you can check this using the Magicbit. On the Magicbit also near to the push button, the pin number is marked, or else you can check the Magicbit pin out and get the pin number. So left push button is with pin number 35. And as we are going to take an input to the system through these, we will define it as pin.in. Like that, then I need to define the buzzer pin. So I will name it as buzzer. That is equal to the pin number. Buzzer is connected to pin number 25. And also from the buzzer, we are taking an output because sound is coming out from the system. So it should be pin dot out. So these are the two components that we are going to use in our activity magic toad, push button and the buzzer. If you using the right push button, you can change the name as R button, or you can use any name here, and pin number should be 34. And it also a pin.t because it is also an input. Now after defining the buzzer pin, we have to initialize the buzzer. There are some details related to the buzzer we need to initialize at the beginning of the program. So let's see what they are. So in the buzzer, we have to define it is a PWM type signal from the above defined buzzer pin. And the duty of the buzzer at the beginning, we need to keep the buzzer off. That means no sound out should come at the beginning of the program. So the duty of the buzzer, we have to keep it very low. Here we are not going to use it at 0. We are going to use it as 1. This 1 is not the digital one. This is just the number 1, right? Value 1. So the above buzzer, you can do this in a separate line, or else you can do this in the same line that the buzzer pin configuration also. So PWM, and here within the brackets you have to give the name you given to the earlier line. There you have given the same name buzzer, no? Right? Like this. Or else you can do this. So for the moment, I will make this a comment. And you can do the same thing. You can put PWM part here and rest of the things within the brackets. So initialization and the configuration of the buzzer pin is done in the same line. Or else you can do, instead of this PWM and these outer brackets, you can do this like this, right? So I'm using it in the same line. And then we have to define the duty of the buzzer. That means the value of the buzzer, we need to keep the buzzer off. So we'll keep buzzer. So whatever the name you define here, buzzer duty, that should be 1, right? So this is how we configure and initialize the buzzer pin and the push button pin. So after initializing, oh, yes, this is the pin out for the Magicbit. You can see buzzer is for the pin number 25, and the left push button is for the pin number 35, and right push button is for the pin number 34. You can see these 3 pin numbers here at the Magicbit device also. Near to the components, it has marked like this kind of white color circles. So there also you can see that. And then now we are going to define a function called play tone or the tone function. So that means the function that we need to run to activate the buzzer. So we need to define a function. So this function name, you can use any name. So here I have used the play tone. And what are the things or what are the data that required within the program to run this function is, here we define as the frequency of the sound output that we are expecting to have from the buzzer, and the duration of the tone. So when we give the values to these two variables or these two requirements, and when we call it, we can have the output from the buzzer. So let's define this function. To define the function, we need the keyword def. So then you can type any name for the function. Here I'll use the same name, play tone. And with what are the things you need to run this thing is the frequency and the duration. And there should be a double dot symbol at the end of the line. And then in the second line, you have to define what are the things that to happen under this play tone function. So the first thing is the frequency of the buzzer. FREQ, that is the word preterm. That should be the frequency that we are defining here. So you have to use the same frequency. Then we are setting the duty of the buzzer. Now earlier initially we set the duty to 1. Now we need the duty of the buzzer as a high tone. That means in this time it should be turn on. So we'll define the duty of the buzzer. So buzzer.duty. That should be, you can go for the duty of 0 to 1023. So let's give it as 1000 for the moment. Then you have to define how long you need to keep turned on this buzzer. So in that case, we use the sleep option. Now within brackets, you have to give the time in seconds now. So that time will be the duration you are giving when you call this function. So here it should be the duration. So this frequency and duration should be same as the things that you define within these brackets here. And then after this duration, you have to turn off your buzzer, otherwise it will be a disturb, right? So that to turn off, you need to make the buzzer duty again to 1. So we'll make the buzzer duty to 1 again. That means to turn off the buzzer. Yeah, so this is how we define the play tone function. And now we need to call our function. So if our function to run as a loop, we need to call it under while through, or else we can directly call it. So here in our case, I need to run this program as a loop. That means whenever I press the left push button, I need to have the output. Under while true, first we are defining a condition to check whether the left push button is pressed or not. So last week also I told you that how the high and low or the digital 1 and 0 varies with the push buttons. So it may depend on the pull up and pull down type. I told you that in the Magicbit, the push buttons are pull up. So if push button is pressed, then we have to check whether the digital state or the value of the button is equal to 0. So if that is true, then we are printing the value of the button in the serial monitor of the Tony IDE. And at the same time, we are calling our function, play tone function, with the relevant frequency and the time duration. And then with each tone, we are keeping a 0.1 second gap. Okay, so before go to the Tony, let me show you that pull up and pull down function again here. So this is the pull up. Pull up means when the button is not pressed, it is open. The output is a high, digital high, that means 1. When the button is pressed, output is low, that means digital 0. In the pull down resistors, it is the other way. When the button is not pressed, output is 0. When the button is pressed, output is 1. But here in the Magicbit, we have this pull up. So that is why we are checking whether the button value is equal to 0 in order to check whether the button is pressed or not. Yeah. So here now we define the function. So now we are going to call it. So I need to call it as a loop. So I will use while true. This double dot should be there. And then we are defining the condition if what is the name we given to the button is L button. So you have to use the same name you given to the button, L button dot value. To check the equality as a condition, here we use two equal symbols. That is a rule in the Python program. If the button dot value, L button dot value is equal to, so there should be a empty brackets, right? Equal to 0. That means if the button is pressed, then what is to happen? Then we need to play our tone function, play tone function. We are calling the play tone function with the frequency of 2000 and a duration of 1 second. So you can change the frequency from 0 to 2000 and the duration is the time in seconds. So you can give it as 0.5, 1, 2, 3, whatever the time you like. And yes, before playing the function, I need to print the value of the button. So then I can see whether it is pressed or not through the value also. So the button value is print on the serial monitor. So that's why I am directly using the print without defining any other. If you need to print the button value on the Magicbit display, so then you have to import the I2C class from the machine here. And also you have to initialize the OLED display and then you have to use that, right? So you know how to use that in the Python. So later you can try out with that. Here I am just showing you the basics. So what I am printing is, I am printing L button dot value. And after play in this function, I'm keeping a gap of 0.1 seconds, right? So what we did, this is the program. What we did here is we call the libraries and relevant classes of them, and we defined and initialized the button related to the pins related to the push button and the buzzer, and then we define a function to play the buzzer or to activate the buzzer, and then we call that function with the condition to check whether the button is pressed or not. Okay, so now let's run the program. So when you run this program, when you get this kind of thing in your console or the serial monitor, that means your program is running, but you can't hear anything. The reason is we are checking for a condition to press the button or left push button. So when you press the left push button only, you will hear a sound out. When you press the left push button, this one, you should hear a sound out from this buzzer. Here in the program, I have done a mistake. That means in this play tone function, this buzzer dot duty, it shouldn't be 1000. It should be 512 maximum. Right? So now when you run the program, you could see when you press the left push button, see the button value is printing here. If this condition is true only, we ask it to print the button value, or else if you use this line just before the condition, you can see when we release the button, it will print 1 forever, and once we press it, it will print 0. Now here we can see 0 only because we call that if the condition is satisfied. So when you press the push button, you could hear a voice sound out from this buzzer, a beep sound, right? It will play until 1 second and stops because we call it to run for the duration of 1 second and make the buzzer off. Once you press it again the play tone function will activate and come the buzzer output. Yes, so we did our magic tone activity. We checked how to use the buzzer, how to activate the buzzer using the push buttons and using the Magicbit and Python language today. So if you need to learn more things about Magicbit regarding anything about Magicbit, you can visit Magicbit official website. This link is given in the description box below. You can use that. So thank you so much for joining today with us. Let's meet on our last session on this Python with Magicbit program on next week. Thank you so much once again.